Hey everyone, welcome back to the deep dive. We're here today to really get into something kind of groundbreaking.
Yeah.
It's how quantum computing is gonna totally change AI, like way better, way faster, way more accurate, and able to grow in a way that actually makes sense, you know?
Yeah.
So this is all based on some really interesting discussions about generative quantum AI from back in January 22nd, 2025.
Right.
And what we're going to do today is pull out like the biggest, the most important ideas, explain what this whole quantum leap means, and what it means for all of us going forward.
Absolutely.
So before we jump in, just a quick note. We're always gathering info from all sorts of places, sharing the latest updates here.
Yeah.
This AI info is really for learning and having fun. And
Of course.
while we really try to be accurate, we can't guarantee it.
Yeah.
So, please use this info responsibly and ethically. This isn't like professional advice.
Absolutely.
I know what's so cool about this whole thing is we've got these amazing AIs, these large language models everyone's talking about.
Right.
They're doing some crazy stuff, but they're kind of hitting a wall when
Uh-huh.
it comes to how much computing power they need, the energy they suck up, and even how accurate they can really be.
Right.
So quantum computing might be a totally different way to solve those problems.
Exactly.
It offers this like completely different approach, a paradigm shift, really,
That's right.
that might just be the answer to these big roadblocks that we're facing with current AI technology.
Yeah, we're really at an interesting point with how AI is developing these large language models.
Right.
I mean, they're powerful,
Yeah.
but when you think about using them in industry, in businesses,
Yeah.
some serious limitations pop up.
Okay, so let's talk about those limitations.
Sure.
What are the biggest hurdles these AI models are hitting right now?
Well, first you got to think about the sheer scale of these things.
Yeah.
We're talking massive, complex systems. Training one of these advanced language models
Right.
means it has to process mountains of data,
Yeah.
like billions, even trillions of data points, parameters we call them.
Right. And all that number crunching, that takes some serious computing power.
Exactly.
We're talking huge data centers packed with powerful machines
It's not easy.
just to get these AI models working.
Exactly. Often you need thousands of graphics processors or even more specialized hardware
Right?
all working together. Now, this is where things get a little tricky
Yeah.
because this has a real impact on the environment.
Right.
Just to train one well-known language model, it reportedly used up something like 1,300 megawatt hours of electricity.
Wow, that's a crazy amount.
Yeah,
How much energy are we really talking about here?
that's about the same as the yearly energy use of about 130 homes in the U.S.
It's a lot.
Yeah, that's a pretty big environmental footprint.
Yeah.
And it's not even a one-time thing, right?
Yeah.
That's just for the training. These models need to be running all the time to answer our questions and requests, right?
That's right. They're constant operating costs too.
Right, so every interaction, every question we ask, it
Mm.
all adds up. Exactly.
Mhm.
And despite all this, the high costs, the energy use, the limitations and how accurate they can be,
Uh-huh.
the trend seems to be towards building even bigger, even more complex models.
Right.
It's an interesting direction.
It is. And that's where quantum computing steps in. It's not just a small improvement, it's a potential revolution in AI,
It really is.
offering a more sustainable, efficient, and ultimately more powerful approach.
Yeah.
It could change everything.
It really could. The potential is there for a much more sustainable and powerful form of AI.
Right.
Quantum computing could slash the costs of training and running these models
Right.
while making them way better at handling complex problems.
Yeah.
It's all about breaking through those limitations we've been talking about.
So quantum computing is creating a lot of excitement in AI, especially when it comes to how we understand and use language. They call it quantum natural language processing, or QNLP.
Mm-hmm.
And it sounds like it's not just about doing the same NLP stuff on quantum computers. It's
Yeah.
about completely rethinking the whole approach,
You got it.
rebuilding it from the ground up
Yeah.
to make the most of what quantum computers can do.
That's a really key point. It's not just about taking what we use today for NLP and running it on quantum hardware.
Right.
It's about taking those core ideas
Right.
and reinventing them to use the power of quantum computers.
So you're talking about things like how machines understand words,
Exactly.
how they understand the context of sentences, and even the whole structure of these models,
Yeah.
and finding ways to translate all that into the quantum world.
Exactly. The goal is to reimagine these fundamentals
Right.
in a way that truly uses the power of quantum mechanics. They're deliberately trying to avoid just copying and pasting the math from classical systems onto quantum systems.
Yeah, because quantum systems operate so differently from classical computers.
Wow.
We're talking about things like entanglement and superposition,
Right.
which don't exist in classical computing.
That's right. These quantum phenomena offer completely new ways of computing.
And that's where the potential lies, right? Designing AI models that are inherently quantum from the ground up
That's the idea.
to unlock these computational advantages that traditional methods just can't achieve.
Right. And what's really cool is
Yeah.
all these advancements, all this stuff that sounds like science fiction,
Yeah.
it's becoming reality thanks to how quickly quantum hardware and error correction are developing.
So let's get into some of the specific breakthroughs that are happening in QNLP. One that really stands out is quantum embeddings.
Mm-hmm.
In classical AI, words are represented as lists of numbers, like coordinates in a high-dimensional space.
Exactly.
But how do you do that in the quantum world?
It's fascinating, really.
Mm.
Instead of using those lists of regular numbers, the real valued vectors,
Yeah,
like in classical approaches like word2vec and glove,
right.
quantum word embeddings use what are called complex valued vectors.
Okay, that sounds pretty technical.
Yeah.
But is that connected to how quantum mechanics actually works?
It is. It really is. In quantum mechanics, you describe the state of a quantum system using a vector in a special space called Hilbert space,
Okay.
and it's a complex vector space. So by representing words as these complex vectors,
Mm-hmm.
it lets you map language directly onto the core components of quantum computers, parameterized quantum circuits, and the qubits themselves.
So it's a more natural and maybe even more expressive way of representing language
Right.
in the quantum world.
That's the idea. This use of complex numbers might offer big advantages. Natural language is very nuanced, with all these probabilities and layers of meaning,
Right.
and complex numbers could capture those nuances much better than just real numbers.
So the next area you mentioned was quantum recurrent neural networks, or RNNs.
Uh-huh.
Classical RNNs are great for understanding the order of things, like in text.
Yeah, they're good at processing data that comes in a sequence.
Right, so how are they being redesigned for quantum computing?
Classical RNNs are really good at handling sequential data, like text. The quantum version uses something called parameterized quantum circuits, or PQCs. It's kind of like a hybrid approach, where the quantum circuits do the heavy lifting, and classical computers handle the fine-tuning of the quantum system.
So it's like a team effort
Yeah.
between classical and quantum computing.
Exactly.
And you mentioned an experiment where they actually tested a quantum RNN against classical RNNs.
Right. There was a really interesting experiment.
What were the results?
Well, they used a quantum RNN to classify movie reviews as positive or negative. And get this,
Yeah.
this quantum model, running on only 4 qubits, performed as well as some of the best classical RNNs,
Wow.
even more advanced types like GRUs and LSTMs.
That's impressive, especially with so few qubits.
It is, right?
What does that mean for the future of AI?
So there are 2 big takeaways. First, it shows that quantum models can achieve the same level of performance while using a much smaller representation space, meaning they might need less quantum resources.
Right.
Second, it suggests that we could see massive energy savings with AI in the future.
That's pretty huge.
It is.
You also mentioned a partnership that used PQCs for peptide classification,
Yes.
which sounds like a very different application.
It is.
Yeah.
What was that about?
So this was a collaboration focused on computational biology,
Okay.
specifically on designing therapeutic proteins. Using a quantum system, they were able to classify sequences, which is super important in that field. And again, the quantum approach was just as good as comparable classical methods.
Okay.
It was an early win,
Yeah.
showing how we can use near-term quantum computers to tackle real-world problems in science.
That's really cool.
Yeah.
Okay, so let's move on to quantum transformers, or quick COCO. Classical transformers have been really transformative in NLP.
Yeah, they've changed the game.
They're behind a lot of the recent progress we've seen. So how is quantum computing approaching this architecture?
So classical transformers are powerful because they can process different parts of a sequence at the same time,
Yeah.
which is something traditional GPUs are good at.
Right. But quantum computers don't have that same kind of parallelism.
Okay.
So they developed Quixer, a quantum transformer model that's specifically designed to work well on quantum hardware.
So it's not a direct copy of a classical transformer,
Right?
but a version that leverages the unique strengths of quantum computation.
Exactly. They used fundamental quantum algorithms as building blocks.
Okay.
So Quixer uses as few qubits as possible. In a recent study,
Yeah.
this quantum transformer was used for a real-world language modeling task. and the results were comparable to classical transformer models trained in the same data.
That's another big step, right?
It
You
is.
said it was the first time they used a quantum machine learning model for language with real-world data.
Yeah, that's right.
That's amazing.
It's really exciting seeing quantum models going beyond theory
Yeah.
and tackling real-world language data.
Okay, last but not least, you mentioned quantum tensor networks.
Uh-huh.
What are those and how are they being used for NLP in the quantum world?
So tensor networks are like fancy math tools that help you represent and work with large amounts of data.
Okay.
They've been used in all sorts of fields, from quantum physics to image recognition.
Wow.
For NLP, they can be used to classify sequences of words based on their meaning.
And are they testing these on actual quantum computers?
They are. They've done experiments with a quantum system, and the
Yeah.
results show that they can perform as well as classical models for similar tasks.
Wow.
This was a big deal because it was the first time a scalable NLP model was run successfully on real quantum hardware.
So you mentioned that these quantum tensor models seem to fit really well with certain features of quantum computers.
Yeah, the way they're organized, often in a tree-like structure,
Right.
works well with certain quantum architectures,
Oh,
like
right.
being able to take measurements during the computation and reuse qubits.
Right.
There's even this cool parallel
Yeah.
between the tensor networks used for NLP and those that describe how the quantum processor works.
Okay, so let's step back and look at the big picture. What if we learned about running AI on quantum computers?
Well, it's early days, but there are really promising signs, especially when it comes to energy efficiency.
Right.
There was a recent result in something called random circuit sampling, which is used to compare the power of quantum computers to classical supercomputers.
Okay.
The quantum computer used 30,000 times less energy to achieve the same result.
30,000 times?
Yeah.
That's unbelievable.
It's crazy, right?
Do you think we'll see similar energy savings with quantum AI models as they become more advanced?
It's definitely possible. The thinking is that as quantum AI models grow,
Yeah.
their energy use might scale much better than classical models,
Okay.
where energy demands can really explode as they get bigger and more complex.
And you also mentioned that quantum models seem to need fewer parameters than classical models,
Right.
which can have billions of parameters. So
Exactly.
that's a big difference.
Yes.
So what does all this mean for the future of AI and its impact on society?
As quantum hardware keeps getting better, we'll likely see quantum AI models working alongside or even replacing classical systems in certain areas.
Yeah.
The potential for saving on costs and energy, thanks to quantum phenomena like superposition and entanglement,
Right.
could make AI much more sustainable and accessible for all sorts of applications.
So all this work in generative quantum AI,
Yep.
it sounds like it's the start of a whole new era for artificial intelligence.
It really does. Combining quantum computing with AI could completely change how we understand and process information,
Yeah.
leading to more efficient and powerful systems that can handle the full complexity of language, other tough challenges. The quantum computers being used in this research are some of the most advanced out there, giving
Right.
us a glimpse into what the future might hold. The hope is that all these advancements will lead to a time where this work has a real and positive impact on society.
Well, this has been a fascinating look at how quantum computing could completely change AI, especially when it comes to understanding and using language.
Yeah, it's pretty mind-blowing.
The idea of having more sustainable, efficient, and powerful AI is definitely something to watch closely.
It makes you wonder how these quantum AI advancements
Yeah.
might change how we interact with technology and information in the future. I mean, who knows what kind of breakthroughs are possible?
Absolutely. If you enjoyed this deep dive, please hit that like button, subscribe to the channel, share this with anyone who might be interested, and leave a comment below with your thoughts or any questions you might have.
Yeah, we'd love to hear from you.
Thanks for listening.
See you next time.